All right, guys. So we're going to be talking about adding in our first rigging option or rigging system into our character. And that's going to be using what's referred to as FK or forward kinematics, as well as the ribbon spine system. So, just real quickly, a forward kinematic system is basically a set of controls that are nested under each other and allow you to have direct control over a joint system. So they are basically either just uh, orient constrained or parent constrained to each one of these joints. And you see each of these controllers here. Okay. And then they just basically just control it directly. Now they are using what's referred to as a parent constraint, which is different than the parent, the nesting parent. Nesting parent, you would have a controller and a joint, controller and a joint, controller and joint, kind of in a tree. Using the constraints, you can see that we have these parent constraints basically as children under each one of the joints, and that actually links it to a different controller, which is kind of cool. This is important because this allows us to swap out bits and pieces if we need to. We can do repairs. We can also key in and key off, key on and key off parent constraints where we can't do that with nesting parents. So if I wanted to have like an object being held by one character, I can turn it on and off as I need to. So the object can be dropped or tossed or held or whatever. Okay. The FK system um, really depends on having a parent and then children that subsequently are nested under each other um, throughout this. It's a very simple system to do. It's super common to use. Okay, it's a pretty basic system, so we'll go over that with this project. Additionally, also I have the ribbon ribbon spine system. And so this guy, let me turn off my joints. What else am I missing? Yeah, that's correct. I'll turn off basically all of these and then reset it to 0. So the ribbon spine is essentially a FK system that has um, a intermediate joint chain inside of it. So the FK system you can see here in the arms. When I move the joints, you'll see that the controller moves the joint directly. You see that each one of these joints is moves at a 1-to-1. Now, the thing with this, though, is that we have a system basically where we have a NURBS curve that is allowing, um, that basically is a host to a joint, series of joints that actually sit right on this path. And let me go and turn that on. So I believe it's hidden somewhere. There it is. Ribbon spine group is right here. There you go. So we have this NURBS curve. It's not a polygon curve or not a polygon surface. It's actually NURB surface. And the NURB surface, you can see, has these little joints that are sitting on the surface and actually go along with it. And you see as I move the controllers, the NURBS plane follows. It actually follows the joints, the control joints. And then on top of that, or sitting on it, is going to be these little joints right here. And those are actually following what's referred to as follicles. And the follicles, you may think of like hair when you hear follicles, and that's exactly what it's for. It's for a hair system. but we're using them as a way to kind of attach these little joints right here to this plane that then follows this other joint system. Now you're probably wondering, like, well, what's the point? So for stretchy, ribbony objects, a ribbon spine is really good because it allows you to kind of have a bit of a fall off and a stretch factor that we might not normally have. So if I just grab, let's say this guy, see how I pull it over this way? Now what's going on is the joint is following, but then it's stretching the ribbon in between these two joints, which is kind of cool. It basically allows us to have a really nice stretchy system that has a fall off on it. So things like tails, tentacles, tongues. It can be used really well with like snakes and worms and all sorts of stuff. You can use this basically to set that up, and this is good for use in spines, hence the name ribbon spine. And so it's, if you think about it this way, it's an intermediate system that is controlled by an FK system, FK chain. The ribbon spine is really broken up into basically a ribbon NURBS plane right here, which has follicles attached to it through the hair system. And then those follicles each have, if you look right here, each have a joint underneath them. So follicle, joint, follicle, joint, okay? And those joints are actually what is skin to the mesh. So the squid mesh itself actually is skin to this. Whereas the control joint, this guy, is not actually skin to a mesh. It doesn't actually control the mesh directly. It does indirectly. So maybe it's a little bit confusing, but once you kind of set it up, you'll see how it kind of works, and you'll see why it's a good system to use. So I got 3 of these set up on this rig. I have one for each tentacle, and then I have one for the mantle. Let's see how it works. Again, it gives you a really nice kind of rubber bandy look, and it smooths out movement that needs to have a bit of a curve to it. Feels pretty useful. All right, next video we'll get started.